Hello students, welcome to Shruti Academy. So let us start with another topic of electrical engineering, which is the efficiency of a transformer. So we already know what is efficiency in a day-to-day life also. In the all the devices, we measure the efficiency by the output to input. How much input we are giving and how much output we are getting. That defines the efficiency of any device. So over here also, the efficiency of a transformer, we measure the output power and the input power, and the ratio of the output power to the input power is defined as the efficiency of the transformer. Okay, so we give the input, and the transformer is a device that transforms the voltage from high to low or low to high, and then at the secondary side we get the output power. So how much output we are getting, that defines the efficiency of a transformer. So let us write down the formula for the efficiency. Efficiency is given by output power to the input power. Now the input power is also responsible for the losses, as well as for the output power, how much output it is giving. So the input power is given by output power plus losses. Okay, plus the losses. So losses are of two types, the major losses and the minor losses. Minor losses can be neglected, but the two major losses are there, which are the copper losses and the iron losses also. Okay, that also we have seen in the previous videos, the iron losses and the copper losses. Okay, so the iron loss given by Pi can be determined by the open circuit test, and the copper loss can be determined by the short circuit test. Okay, since the ordinary transformer also has the efficiency very high, about 95 to 99% is the efficiency of the ordinary transformer. So directly we cannot find the losses. So with the help of these tests, we need to find out. Directly we cannot find the input power, directly we cannot find the output power. So with the help of these tests, we can find out the losses, and we can substitute the losses, the value of the losses over here, and we can determine the efficiency. So our efficiency formula becomes output power upon the input power, or rather in the place of input power we'll be writing here the output power plus the losses. Losses are of two types, the Pi and PCU. This is the general form of the efficiency formula. General efficiency formula. Okay. Now for the different cases, we need to find out the efficiency for the full load, for the fractional load, and for the maximum load. Okay, maximum load. So the formula for the efficiency will be output power. Output power is given by V2 I2 cos phi 2. V2 I2 cos phi 2. Since the output is determined at the secondary side, so the secondary voltage, V2 is the secondary voltage, I2 is the secondary current, and cos phi 2 is the power factor. Phi 2 is the power factor. Okay, so output power is given by V2 I2 cos phi 2. So we'll be putting over here the value. So V2 I2 cos phi 2 upon V2 I2 cos phi 2 plus Pi is the iron loss. Copper loss. Copper losses are given by I square R. These are the I square R losses. We have already learned about them. We have already discussed about the losses. So they are the copper losses. So they will be given by I2 square RE2. RE2 is resistance referred to the secondary side. Resistance is referred to the secondary side, and since they are the I square R losses, so the secondary side we are referring, so I2 square we have placed over here I2 square. So this forms a formula for the efficiency. Okay. So now let us see for the fractional load. Okay, let us see what happens for the fractional load. This can be used for the full load. This can be used for the full load when the load is full. Now in all cases the load cannot be full. Sometimes the sum of the fraction of the load is being applied, like 3/4 of the full load, or you can say 75% of the full load, or you can say 40% of the full load is applied to the secondary side. The load is in fractions. So at that time the formula changes. So let us see how the formula changes. Okay, so for the fractional load, we need to determine how much fraction of the load is being applied. How much fraction of the load is being applied over there. Okay. So for that, firstly, we will be finding out the fraction. The fraction is given by x. You can denote it by any of the constant, no problem. Okay. So x is given by the full load, the current. Sorry. X is given by the current upon the full load current. Current in the secondary side upon the full load secondary current. That means X is given by I2 upon I2 FL. FL is the full load. FL is the full load. So I2, secondary current, from here we can find out. Secondary current will be equal to, this will go that side and it will go with the multiplication. So it will be X into I2 FL. So in the place of I2, we'll be substituting X into I2 FL. Okay. So our efficiency will now become V2 X into I2 FL cos phi 2 upon V2 again X I2 FL cos phi 2 plus Pi plus I2 square RE2. Okay, so this forms our efficiency formula for the fractional load. Okay, now over here, if we look over here, if we combine these, so this will be VA ratings, V and I. Okay, V for voltage, I is for amperes, VA rating. So efficiency is given by X into VA rating cos phi 2 is the power factor upon Again x over here we are taking out. Again reiterating. Again it is the power factor plus pi. Yes, over here we need to put I2 value. We left over here. And that I2 value will be x square I2 FL square. Okay, so x square will be as it is and multiplied by PCU full load. Okay, these are the copper losses at the full load. So this forms a formula in terms of rating. If the VA rating is given in the numericals, we can directly put the value, we can get the answer. Okay. So these are the formulas for the fractional load. Okay. When the load is not full, but load is in fraction. Now there is another formula which we can get over here for the efficiency is that in terms of the input power, sometimes the output power is not given and the input power is given. So in terms of the input power, the output will from here can be written as output power can be written as input power minus losses. Okay, losses will go to that side and it will go with the negative sign. So in the place of output power, we can put the value of the output power, which is the input power minus the losses. So our efficiency formula will become now input power minus losses upon input power. Okay, or the efficiency will become dividing it, so we'll be getting over here 1 minus losses upon input power. Okay, so these are all the formulas which are helpful in finding out the numerical values, because on efficiency the numericals only come, no theoretical part comes from these formulas. It comes as it is, the numericals come from this topic. From this topic the numericals are there are most of the chances to come the numericals in the examinations. Okay, so thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.